Hello everyone. In our today's problem, we have to find two sneaky numbers of Digitville. So you will be given an integer array. All you have to find two numbers which are duplicates. Okay. So in an array, the numbers uh, 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 in an array list called nums containing integer from 0 to n minus 1. Okay. So for example, if n is equal to 2, so there should be numbers, or for example, if n is equal to 5, there should be numbers till 0 till 4. Okay, so the line should be 0, 1, 2, 3, 4, like this, and the line should be 5. Okay, now the problem statement says you'll have two sneaky numbers, means two duplicate numbers. So our nums array will look like this, something like this: 0, 1, 0, 2, 3, 1, 4, something like this. Okay, so here if you have a look, 0 have twice and 1 have twice, two times. Okay, so the all we have to return, we have to find the two numbers and we have to return it in an array. So our answer will be 0 and 1. Okay, so that should be the answer. How can you find it? The brute force approach is pretty much simple. All you have to do, you have to take an unordered map, and then unordered map will like we will be storing all the frequency. So for this, like when we will go to 0, the frequency will be 1. Then we will go for 1, the frequency will be 1, then we will go to again 0, so the frequency was 1, then we will add plus 1, which will be 2. So if it is 2, we will store it in our like response array. So we got 0, then again for 2 it will be 1, for 3 it will be 1 again, and again we got 1, so it will add 1 here, so it will be 2, so we'll be pushing 1 in our response array, then our output will be 0, 1. That's it. As long as like uh, whenever we get the response and the size is 2, we can immediately return the response, right? Because the if you have a look at the constraint, it says like the input is generated such that nums contains exactly two repeated elements. Okay, now like that's the brute force approach. So if you have a look, it will cost you of n space complexity. Okay. If you wanna say space, either you can consider time complexity, like time complexity will be bit up, like so. For example, a bit high. For example, this one was 0, 1, 0, 2, 3, 1, 4. So 0, 1, 0, 2, 3, 1, 4. This one was our array, right? Now, without taking another map, we can like sort this array, right? 0, 0, 1, 1, 2, 3, 4. If we sort this array, our duplicate value will be together, and we can say if my current index is equal to my previous index, push it to the response, and then like will be like uh return the response as answer. That's it. So the space complexity will be 1, but the here the time complexity will be log n log n. So there's another one. If I code a little bit about the another map, so you can understand. Another map, int, we can see, and then I can say vector int response, return response. And I'll say for INTN nums frequency and plus plus. Then I will say if frequency and is equal to 2, then response dot push back, and that's it. And here you can also say if response dot size is equal to 2, then return response. That's it. If we run this one, it will get accepted. If we submit this one, it should be get accepted. It is. Now, instead of frequency array, what we can do, we can sort this response, sort this number. So, sort nums dot begin, nums dot end, and here we can say anti-I equal to 1, I less than nums dot size, I plus plus, as the same. We don't need this one. If we can say if nums of I is equal to nums of I minus 1. That's one to push back nums of I. If response size is 2, we'll returning response. That's it. And if we submit this one, it should be get accepted as well. Yeah, that's it, guys. So this is the two brute force way to solve this question. Now we have another way to solve it, which is called bit manipulation. So we all know how to use XOR, right? So here, mm, yeah, so if I remove this one from here, so here, if we have a look, what should be the size actually? The actual size should be less, le 2 less than from my original size, right? The actual array should look like this, right? 0, 1, 2, 3, 4, right? Means the size should be 5, not 7. So actual size should be my current size minus 2, right? Because there are two duplicate numbers. Now, this should be the actual size. And if we got size, size will be 5. We know how many numbers will be there. It should be 0 to 4, right? So it should be 0 to 4 numbers here, right? We got it. Now, if we know this one, we can find it out very easily. Sorry, how can you find it out? So, all you have to do, you will get the XOR from here of this array, right? So, 0 XOR or XOR 0, 1, XOR 0, XOR 2, 0, 3, 1, XOR 4. You get 0 XOR of this, and then XOR of 0, 1, 2, 3, 4. So if you do XOR here, it will give you the difference one, like because the 0 and 0 will cut, 1 and 1 will be cut, 2 and 2 will be cut, 3 and 3 will be cut, 4 and 4 will be cut. So you'll be getting 0 and 1 here, right? 0 and 1. So the answer will be 0 or 1. Okay. Once you get the answer, Once you get the answer, if you have a look at the binary form of 0 is 0, 0, and binary form 1 is 0, 1. So here is the difference. Means our difference index is our zeroth index, right? Zeroth and 1th. Okay, so here is our difference. So if you get the difference and if you try to get the, you know, if you wanna separate the whole array base with the difference, you can do it. So our A will be 0 and our B will be 1, then again 0, because 0, 0 will be 0, 0, 0, 1, binary form 0, 2, 1, 0, 1, 1. What is this? Right. So 0, 1 and 4 will be 1, 0, 0. So it will be 3 digit, 3 digit, 3 digit, 3. Right. Now on our first index, if it is like 0, it will come here. If it is 1, it will go there. So 0, got 1, got again we got 0, 2, 3 will go there, 1 will go there, 4 will come here. Okay, so we got two arrays, right? Now all we have to do, we have to push it. So we have to push from the original array. Okay, so 0. Okay, this 1, 2, 4, and then 0 will come here, and here our B will 1, 3, 1. So 1 will come here, 2 will go there, 3 will come here, 4 will go there, right? Now if you do XOR here or XOR here, 0, 0 will be cutted, 2, 2 will be cutted, 4, 4 will be cutted. You'll get 0 here, 0 here, and then on the B, 1, 1 will be cut, 3, 3 will be cut, it will be 1 left, so 1 will be there. So answer will be 0 and 1. It's pretty much simple. That's it, guys. And how can you get the leading zeros? Or like, how can you get the, for example, the binary number is 0, 0, 1, 0, 0, 1, 0, 0, 0, 0. How can you know like how many leading zeros we have on our binary number? So in C++, there is one function called, if I show you the function called mm, built-in, let's built-in, built-in, and then again underscore dot c count total ctz or z count total 0 of number. So if you do this, you will get total zeros means 4, 4. Okay. Then if you do 1, this one 4, it will create a number like this. Okay. 4 zeros and 1 1 like this. It's pretty much simple. So all we can do first, all you have to know like what should be our current number, current array length. It should be n minus 2, right? Or the size minus 2. So I can say n equal nums dot size minus 2. Then what we can do? mm, Okay, we'll be doing the XOR for both of arrays. So I'll be saying XOR. XOR. Just copy this. So the initial value will be 0. Then I'll be running loop for int n nums. Then 0 will be that's it. Then I'll be running one loop. For nums, I have done 0. Then for array, it will be for int I equal to, I'll be starting from 0, I less than n, I plus plus, because there will be total n minus 1 number. Again, so will be, that's what we got. Then I need leading zeros. How many leading zeros I have? So int leading zeros will be or built-in C++ library will be underscore underscore built-in build BYL and built-in again underscore count CT z count total 0 of zar. That's it. And then I'll be create and a point, or we can say main, or we can say, yeah, we can say mask. Mask will be 100 leading zeros. Leading zeros. Okay. Now we got our mask. Once we get our mask, we have to separate A and B. So A will be 0, initial value will be 0, B will be initial value 0. That's it. Then for at first, uh, I'll run on the numbers. So for int and nums again, I'll be keep separating A and B. So if and then we can say yeah and or no, not and this is if and yeah and mask, it should be mask is equal to 1. Then what we can do, it will go to n. It will be as or n, yeah, otherwise it will be b or n. That's it. Else for n we have done, and for like total numbers means, so I can say for n equal to 0 and less than uh, this one is n as well, right? So we'll be saying I equal to 0 and I less than n, I plus plus. So here the I and must, it will be like this, and at the end it will be returning a, I bet, a and b and colon, and if I run this one, should be accepted. Okay, yeah, it's accepted. And if I submit this one, it is accepted, guys. Thank you so much.